Good evening, everyone.
Good evening.
How are you?
Yeah, fine.
Yeah, you're good.
Yes.
Okay, so welcome to YouTube. I introduce you to a new unit, which is digital electronics, and then we shall look at what is expected of you by the end of this session. Okay. So before that, I'll take a roll call to see who is present and who is not present. So I'll start with Frederick.
Present, sir.
Robin.
Present.
We have Morris.
Present, sir.
Enoch.
Present, sir.
Glenn.
Present.
We have Ruth.
Present.
Kennedy.
Present.
We have Peter.
Present.
We have Amos. So I think everyone is okay and is present. So our unit, as I was saying, is digital electronics. So today being 17, 12, 25, the unit is digital electronics. Then the learning outcome for today is by the end of this session, you should be able to find number systems. Which is decimal. We only have this outcome for today. And the topic is number systems. So this is our first topic, number systems. Our subtopic is decimal system. So I'll try to bring your mind back to your academics. You talked of in mathematics, you're talking of place value, total value, and so on when you're studying maths in primary school and in high school. So the decimal number system is an advancement of what you previously know. So we have some key aspects that you have to know for decimal number systems. One, we say that decimal number system, it uses a base radix of 10. A base radix of 10, I mean that if there's a number A, then it has to have a base of 10. So if you present a value in such a way, then we call it a decimal system. So another key factor that you have to know is that it has 9 significant digits. We use 10 significant digits. And those digits, they start from 0 all the way to 9. So that's also another key factor to know for a decimal system. And another key factor to know is that each digit is represented by the powers of 10. And this 10 is a common factor, and those powers, they are represented in ascending order. So that is how we know that this number satisfies to be a decimal system. So after that, at least we are together?
Yes.
Okay, so I can go with an example. We'll see how we can represent a number in a decimal system. I can pick a number like 345. That is 345. If you look at this number, if you want to break it down, following these key aspects that we have seen, then it means you have to write 3. If you look at the base value, you start from the right, 1, 10, 100. The total value is 300. So 3 can be represented as 3 by 10 power 3 because it starts with the ascending power is 0, 1, 2, that is 2. Then you can add 4 by 10 power of 1. Then you can add 5 by 10 power 0. So if I use that format, then we have already broken down this number into a decimal system. And you can write your answer as 345 from base of 10. So with that you have at least transformed that number to a base of 10, which is a decimal system. At some other points, you can find a number that has not been written any base at the bottom. So at the back of your mind, it tells you that these are a decimal system. So up to there, are you okay?
Yes.
I can give you a brainstorming question whereby you can break down this number 64, 21. You can try breaking down 64, 21 into its equivalent decimal system. So it's just like following these steps, looking at the total values of each, following the order of the ascending order, which is from 0 to 1, 2, 3. And then you finally present it back to this with a base of 10. So you can see Morris is already done. So are you getting the same? No base of 10? Yeah, so that's how you present, which is a 64, 21, or base of 10. And then following that, it can be, someone can ask you, why do we, or where do we apply this number system? So mostly we'll be applying it in the real world, it's applied in computing, and when you're performing some basic arithmetics or basic calculations. That's where we use the decimal number system. Also, I can give you another question. That's to know if you already know the place value and the total values, right? So I can ask you to give me the total value of the 4 in the number 64, 21. So what was the total value? Anyone? The total value of the 4? Yes. 100. Yeah, because if you start from on my far right, 1 is 1, you have 2, 20, 4 is 400, right? Then you can try also this. Now we go to the place value. I want you to guess the place value of 7246. The place value of the 7. So what's gotten it? The place value? 7,000. 7,000? Is it correct, class? The place value?
Thousands.
Thousands. You remember when we are talking about the total value, we are talking just of representing these values in terms of basis of 10. But the place value, we are talking about the exact position where that number is. So if you start with the ones, it is 6 ones, you have 10s, hundreds, then thousands. So that one, when we advance to doing the
You can find the one that you see when you're giving the position of the number 7 and the way it was the previous solution, the position of number 6.
the first time I talked about the total value. The total value can be presented with this form. whereby we present in terms of the exact values. But the place value, we are talking of the position where it's placed. Remember, when you're doing the conversion, you have to know the position of a number. When you advance to the next class, when you're talking of a conversion of one number to another, you have to know the exact position. We use two different ways, the positional notation and this as notation. So that's why I'm trying to at least make you remember if you can be able to differentiate the two. Okay?
Yes.
Yeah. So that was the learning outcome of this. So at least we have gone through the number systems. You can now be able to clearly define a decimal number system. Okay. You can also be able to represent the different types of when you are given a certain position. You can also be able to represent that value with a base radix. And always remember these key factors because you carry them when you are doing the conversions from one form to another, from a decimal to another form. You always have to carry yourself these 3 points. Now that you have understood that, at least that marks the end of the session, and I'll have to leave an assignment for you to carry out and go and practice. Okay? So, the first assignment break down the number 5832 into its decimal equivalent. And represent your final answer with a base radix of 10. So this is your assignment. You will go break down this decimal system into its decimal equivalent, and the final answer you have to present it with a base radix of base 10. So the assignment can be the next class before you finish. So thank you.